we're on page 2, and at the top of the page we're going to look at what does the multiplier, the coefficient a, what does it do to the graph. So we've got f, g, and h again. Notice what they are, just plain old x squared, 3x squared, and negative 1/2 x squared. And here's all the values filled in. We can do the domain right now because the domain's the same for all three. You can square any number and multiply by anything you want. So the domain is negative to positive infinity. I think I'm just going to say, quote, quote, write down that column. We'll look at the range after we get the graphs drawn. So again, we begin with just plain old x squared, where you have points like 0, 0, 1, 1, 2, 4, and 3, 9, 4, 6, 8, 9. I have to count those. And negative 1, 1, negative 2, 4, and negative 3, 9. So here, oh, and let's go one more. Negative 4 up to 16. So that's 10, 12, 14, 16 right there, huh? And on the other side, see, I use the mirror image idea, the symmetry of the graph. That's not too bad for freehand, huh? So that's the f graph. That's just x squared. Now for 3x squared, of course, order of operations says we square the numbers first and then they get multiplied by 3. So, you know, take all these, multiply them by 3, you get those. And at negative 3, we're all the way up to 27. So here's negative 3. That was 16, 18, 20, 22, 24, 26, 27, right up there. And while we're up there, let's go over here. You get the same 27 for y when you use positive 3. And at negative 2 and at positive 2, we get a y value of 12. So that's 4, 6, 8, 10, 12. And again over here, 12. And at negative 1 and at positive 1, we get a y value of 3. And at 0, we still get 0. So the first thing I notice, comparing the two, is that the y graph, the g graph is narrower, you could say skinnier. And when you skinny it like that, you're stretching it vertically. We call that a vertical stretch. We'll see a vertical stretch if the number a is larger than 1. Okay, 3 is larger than 1, like a y equals 10x squared would be even thinner. What happens with the next one? Negative a half times x squared. Well, again, you start by squaring the x value, and then you multiply it by negative a half, which is the same as changing the sign and cutting it in half or dividing it by 2. So I'll read off the table over here. And at negative 3, we're down to negative 4.5, which would be right there. At negative 2, we get negative 2. At negative 1, we get negative a half. At 0, we get 0. And then on the other side, we get these same y values again, the old symmetry effect. And there's that graph. And you see this, and it's kind of hard to see, but if you could imagine flipping that over, maybe I can do this. So we have this a little bit of luxury of time. If I trace that on here, and then put that right on top of that. I don't know if you can see. Can you see through that? Probably not. If I can flash the light underneath. Well, it is wider. Let me do like a flip book. It is wider than the plain old x square graph, if you can see that. And the negative aspect of it is what flipped it over, making it open downward.